Hi everyone, today we're looking at Chapter 11, which covers the introduction to quadratic equations. So we have looked at linear equations as well as exponential equations. Quadratic equations are almost like a mirror image of an exponential equation. They go on to infinity in both directions as opposed to just one direction. And they typically look like a U or an upside down U. So in lessons 11.1 and 11.2, we are exploring quadratic functions and comparing linear and quadratic functions. And our learning target says I can model real-world problems using quadratic functions to be able to analyze tables, graphs, and equations and compare them to linear functions. So in order to kind of discuss this particular target, we're going to look at problem number 2 in our textbook. And I want to just have you keep in mind, this is called the handshake problem. And in order to model this particular example, we're going to be drawing some diagrams that are a little complex. They may not be perfect, but they're just a good visual for us to keep in mind as we collect some data. So we also want to remember that the quadratic function, the standard form of the quadratic function is ax squared plus bx plus c is equal to 0. So the handshake problem tells us that there's a meeting at the CIA and everyone has to shake hands once. So what we want to think about is how many handshakes will there be based on the number of people in the room. So for example, if we think about 2 people being in the room, 3 people being in the room, or 4 people being in the room, how many handshakes would occur in each of those particular incidents? So let's look at 2 employees. If there's 2 employees in the room, obviously there's only one handshake. There's 2 people, they get connected by that one handshake. If there's 3 employees in the room, they get connected by 3 handshakes. And if there's 4 employees in the room, they get connected by about 6 handshakes. So again, we want to make sure each employee is connected to each other employee at least once. So we're going to proceed with the model that we initially designed, and we are going to draw figures for 5 employees, 6 employees, and 7 employees. So when I draw these figures, I'm almost making them like a pyramid, where the first employee is the point of the pyramid, and then the remaining employees create the base. That just allows me to connect all of those employees without overlapping any lines and potentially miscounting my handshakes. So with 5 employees, I've made a square base pyramid. With 6 employees, I've made a pentagonal-based pyramid. And with 7 employees, I've made a hexagonal-based pyramid. Again, the pyramid base is going to be the shape of the polygon, which is 1 less than the number of employees because that first employee gets connected to everybody. So this one right here is my hexagonal, and I'm trying the best I can to make all those handshake connections. But if I thought about it and I counted, I'm getting approximately 21 handshakes for 7 employees. Now, moving forward to problem number 5, I want to collect my data. Problem number 3. So I just want to quickly organize my data into a table of values and think about what potential pattern I see within that table of values. So when I look at the values quickly, I'm noticing a pattern. It seems like the number of handshakes is increasing by some kind of multiplication because it's the number is getting greater, but not by any particular sum. I'm also noticing that because of my initial person who does the handshake, it seems like the number that's repeating is less than the number of people who are currently employed. So after I kind of finagle it a little bit algebraically, I get n times n minus 1 divided by 2 as the expression for using the number of employees to find the number of handshakes. Now, if I'm going to put it in quadratic form, I need to just make sure that it's in that a squared plus ax squared plus bx plus c equals 0 form. So I just need to manipulate my terms a little bit and make sure that I clearly have a coefficient and a variable for each one. Part 6, or problem number 6, says to graph on a calculator and also sketch your graph. Now, when I plug my equation, 1/2 n squared minus 1/2 n plus 0 equals 0, into the graphing calculator, I get this quadratic formula, which is parabolic in shape, which just means that it's kind of shaped like a U. And I'm just labeling my graph quickly, -4, +4, 0, and +18 to just give a rough idea of where that data set lies. Now the minimum on the graph was 1/2 and -1/2. But in reality, I don't have 1/2 of a person to shake hands with, and we can't have negative 1/2 of a handshake. So that minimum is not really supported in context. In context, the smallest number of employees I can have is 0, and of course that would lead to 0 handshakes. So we want to be mindful that when we're asking for the relative minimum or maximum, that it's actually makes sense in the context of the problem.